Alright, today we're going to talk about one type of QC that we can do with the Gamma camera that involves moisture getting into the crystal of the actual camera heads. Now those crystals, which are located right here just beneath the collimators, which are right here. These are the collimators, the crystals just underneath it. The crystals are hygroscopic, which means they attract water. That's not good to get water on our crystals because it'll help degrade our images by causing droplets to make formations in the crystal that make it so that the photons cannot completely go straight through the crystal as it would otherwise. Now, those crystals are hermetically sealed, and then they are coupled to the PMT tubes, ensuring that no moisture can actually get inside the crystal. Sometimes that seal is not as good as it should be and compromised, and our images can come up looking a little blotchy. Now, if you're wondering where the defect actually is, there's one good test to do on the camera to check to see if it's the crystal, and that test is called an off-peak flood image. Now, to explain what this is, what you do to do this test is you go ahead and acquire a flood nearly as identical as you would your average daily flood, but you change the peaks, and I will show you how. So we're going to go in to this Philips BrightView acquisition station, and we're gonna go ahead and set up this measles test. And I call it a measles test because you will find it commonly called measles on your flood when there is moisture that has become trapped on the actual crystal. And I'm going to give you a good example of that here in just a minute. So you go in just like you normally would. All the parameters are the same that you would normally have for your daily flood, which this one's already set up to acquire for 5,000 K counts. So we're going to go ahead and proceed. Comes up with the P-scopes like it normally would. It also shows our energy peak with the window on that energy peak. Now, the idea is those contaminations within the crystal, they attenuate photons. So to see them better, textbooks will tell you you can adjust the photo peak so that instead of the center of the photo peak being on the peak of the isotope of cesium here, which is 122, we actually do the high end of the window on the center of the photo peak. Okay, and you do it on both camera heads. Just like that. So you see it peaking on both camera heads on the high end of the window. Okay, once you have that set up, you go ahead and start it like you would a normal daily flood. And you'll notice, when compared to the time of your normal daily flood, this flood will take longer. This normally takes about 3 minutes for our average daily flood, but because we are off-peak imaging this flood, it's going to take nearly almost twice as long. Now, to give you an example of if your camera did have a problem with moisture in the crystal, there's a good example in a textbook. right here, it clearly shows that whole measles idea. Clearly shows that whole measles idea right here. So those blotches you see in that flood, it's obviously a round-headed camera for this picture. Those blotches are the moisture that have entered into the crystal. Now we're going to let this flood acquire and show you what the image will look like without any contamination, because our camera has none. Okay, so now the images have finished acquiring, and it took about 10 minutes. This is what a normal, without off-peak imaging, a normal daily flood should look. It's very uniform. There's no obvious defects. Okay. Now I'm going to pull up how that other flood looks and show you the difference of how it looks on, again, a camera that does not have any problems with its crystal. Now if you notice the difference in uniformity across the image, there are darker and lighter spots. And again, this is intentional because we are trying to better visualize attenuating focal spots from the water that has actually gotten in on the crystal. So we lower the actual peak of the photons we acquire by adjusting the peak like we did, and that enables the spots to show up more because the energy is lower that is actually being acquired on the image. So with the lower energy, it will attenuate more and it will show more defects. Now here we have no defects, so this is just how a healthy camera image would look, acquiring a low off-peak image. Now this applies more to locations where humidity may be high, or your department in general just has a high